Hey there, everybody. Welcome back to General Science. Um, where we left off, we were talking about environmental science and geology. And so going from there, we're going to be talking about plate tectonics next, since last time we talked about rocks and the rock cycle. So, what is plate tectonics? Well, it's all about how the Earth moves and shakes. The continents are not set, they move around, and that's due to these special plates that exist on the surface of the Earth. We're going to talk about that today and kind of what the implications of plate tectonics are in this episode of General Science. So, let's get going. Here's kind of the outline of what we're going to talk about. We're going to talk about some terminology, how the Earth changes, where these boundaries are of these tectonic plates, what are the consequences of these boundaries, and then we'll draw some conclusions. So here's a picture of all the tectonic plates. As you can see, there's lots of them. I'm for the United States, so I'm technically on the North American plate, but there are other plates as well. There's this Caribbean one. There's this plate here called the Pacific Plate. There's one in Australia, the Philippines, Eurasia, South America, this Nazca one, Africa, Arabia, India, Eurasia, right? There's all these different plates. So what exactly is plate tectonics? Well, plate tectonics is the study of how the Earth's crust moves around over time. The Earth, like you just saw, is divided into several large plates of rock that float on the liquid mantle beneath, right? The Earth is made of several different layers. The mantle layer, which is right underneath the crust, is liquid rock. And the plates on top of that are these big sections of rock, and the way they move is the study of plate tectonics. How these pieces move and interact is important because it kind of affects how we live, but also how the planet works. So that's why we're learning about it. So here's what plates look like. The planet Earth is made of many layers. The topmost layer is the crust, and that is what we're going to be talking about, these layers up here. So this is the crust, and it's floating on the liquid mantle, which is what I was telling you about earlier. And then there's the core on the inside. So we're talking about this part up here today. There's lots of different vocabulary that goes along with plate tectonics. First of all, there's two different types of crust. There's continental crust, which is less dense and allows it to rise above denser rock, and oceanic crust, which is much more dense, and so it is often further down. The mantle is that thick layer of molten rock underneath the crust, and that's where the components of rocks and minerals can mix freely, and that's how new crust is created down the mantle. The Earth's core is hot and metallic, and the most common metals down there are iron and nickel, and that's why it is so magnetic. There's a large magnetic field around the world, and that's because of the contents of Earth's core. And then finally, a plate boundary is just an area where two or more plates collide with each other, right? They're not separate floating islands. They do run into each other and touch, and that's what plate boundaries are. So, what are the ways plate tectonics could affect humans? Well, normally, if this was a regular class, I'd have you turn to your neighbor, but let's just move on. All right. So, our plates have changed over time on the Earth. This is all the way back to 225 million years ago, where there was one major continent on the planet, Pangaea. Over time, as you can see, this major continent has shifted and moved until what we see now. Okay, these different continents have moved over time, and they will continue to move over time. This is not how it's going to look in 60 million more years. It's going to look differently. So, Earth's crust is constantly changing. So there's Pangaea with all the different pieces inside of it. So you can kind of see where they all came from. Can you see how we are all connected together? There are some changes right now that scientists are looking in these the crusts. Currently, there's a big rift in Africa, and it's possible that Africa may break into pieces coming from the Great Rift Valley. That is a plate rift, right? That plate might be breaking apart. and the plates that are pushing in the Atlantic, and they're holding the American continents and the Eurasian continents, they're being pushed away from each other, right? As they move, what's going to happen as those things go further and further away from each other? Eventually, they're going to smash into each other on the other side, right? So that's something that we have to watch. How's the Earth going to look in the future? We don't really know, right? These things change constantly, but it's stuff that we monitor. We look after it. Scientists are looking at it all the time. It's not something that we ignore. The scientific community definitely follows tectonic plates and their movement. So here's what the present day looks like. All these lines are borders where the different plates hit, like I showed you earlier. Let's talk about tectonic boundaries and what happens at them. This is kind of the meat of plate tectonics. The first type of boundary between the plates is called a convergent boundary. And this is where plates come together and smash into each other. And there are currently two types of convergent boundaries on Earth. There's a continent-continent boundary where two continental plates run into each other, and a continent-ocean boundary where a continental plate hits an oceanic plate. When a continent runs into another continent, they collide and it results in a mountain range. The Himalayan mountains in Nepal and India are a real-life example of this. The Indian plate ran into the Eurasian plate and it created this big mountain. Basically what happens is one of the crusts hits and one ends up getting pushed down and one gets pushed up, and that's what creates this mountain range. When continents and oceans collide, something different happens. When they converge, the oceanic plates create volcanoes, mountains, and trenches. This is because the oceanic plate is denser, and so it gets subducted, which means it gets sucked underneath the lighter continental crust. So the Andes Mountains in South America is an example of this kind of plate boundary. And as you can see what happens here, the oceanic crust gets pulled underneath, which creates this trench area. Meanwhile, all this rock has been pulled underneath into the mantle, which melts it, and that creates lava, and then eventually volcanoes and mountains. So that's what happens at the continent-ocean convergent boundaries. These volcanoes form. Divergent boundaries are the second type of plate boundaries, and this is when two plates move apart from each other. There are two major kinds of divergent boundaries. There's the ocean-ocean divergent and continent-continent divergent. So continental divergent boundaries, when they diverge, that's when rifts open up, and an example would be the Great Rift Valley in East Africa. Another example, there was going to be a rift valley in the United States. However, that one ended up closing up, but it was slowly ripping apart. And there's a geological formation that still exists from that rift, and it's basically part of the Great Lakes. Is that Great Rift Valley. Oceanic divergent boundaries are a little bit more common, and where they diverge, magma spills out of the ridge and pushes the plates further and further away from each other. And this process is basically just creating new oceanic plate. An example of this would be the oceanic ridge in the Atlantic Ocean. So in the middle of the Atlantic Ocean, there is this kind of like small mountain range under the ocean, and it's just spitting out lava slowly over time, pushing the boundaries further away from each other. The final boundary that you can find at a plate is a transform boundary, and they occur when plates rub against each other. So instead of impacting head-on, they're hitting sideways. They're basically rubbing against each other. So when plates rub, this is often where earthquakes can occur, and plates at transform boundaries can get stuck and then release, making their movement a little bit more erratic than the other types of plate boundaries. Like I said, transform boundaries cause earthquakes, and they displace rocks when they move. And one of the most famous transform boundaries is the San Andreas Fault Line in California, and that area has a lot of earthquakes because these two rocks are moving like this, and as you can imagine, right, that's going to cause a lot of shaking and tremoring as they move. So what are the consequences of boundary movements? Well, there are volcanoes, which are created in subduction zones, and when heavier oceanic plates get pulled under the lighter ones, it gets melted and becomes a volcano. An example of what could possibly happen for a volcano, Mount St. Helens, which is in Washington, erupted and the entire top of the volcano disappeared, right? So this whole section used to be volcano, and now it's down to just this, right? Eruptions can release toxic gas, soot, and debris can be carried by the wind even further away. It can be carried all the way to the other side of the continental United States, which is what happened with Mount St. Helens. And this is some examples of what volcanic destruction could look like. Mountain ranges can also be formed in this time, right? The Himalayas were formed by a continental convergence when the India plate smashed into Eurasia, like I said, and the Andes Mountains were created at a subduction zone, this is here Machu Picchu, which is on top of these mountains. Sometimes there are mountains in really odd places that doesn't really seem like it's on a plate boundary. Both the Rocky Mountains, typo there, and the Appalachian Mountains used to be at plate boundaries, but have since moved over years due to other tectonic movements. So these mountains are no longer in a place where it would feel like that's where they should be. That's because they have since moved away from a boundary, right? There's other things moving them into other directions. Deep sea trenches are created in subduction zones as well, and that's when the continental plates get pushed underneath. It creates kind of a lip, so it looks like this, and it gets sucked in and becomes a trench. And they're basically just underwater valleys. The biggest one is Marianas Trench, which is near Japan. Here we go. The deepest underwater trench in the world, 11,000 meters deep, which is almost 7 miles under the water. Only recently have we actually had the capability to descend to the depths of this trench because of this incredibly high water pressure. And as you can see, it's down here in Asia. Ocean ridges are created by divergent plate boundaries. The rock gets pushed away, and we kind of explained what that means already. And here's where the Mid-Atlantic Ridge is. As you can see, there's an increase in the topography, and that's that ridge. And here's another map of it here. We were able to find it in the 1850s because of what's called a sounding, but now we use thermal imaging. We've been able to discover this ridge. It's 40,000 kilometers long under the ocean, and it's full of active volcanoes. This is why Pangaea broke up, this ridge. And then, like I said, earthquakes. They're just byproducts of tectonic activity. Big pieces of land are moving, and that's going to cause some shaking. Here's an example of the San Francisco earthquakes. Since San Francisco is built on a fault line, it experiences a lot of earthquakes. And back when we weren't so good at construction, it caused a lot of damage. So the earthquakes in 1906 and 1989 were very large, and they caused a lot of destruction. Finally, we're going to talk about what's called the Ring of Fire. And this has a lot of seismic and volcanic activity. It's a big ring, basically just one big plate boundary. It's kind of like a circle, and it's where several plates interact, creating this ring. And the ring has 90% of the planet's earthquakes and 88% of the world's largest volcanic eruptions, because this is just a lot of stuff happening here. All right, so the Ring of Fire is a very important area of seismic and volcanic activity. There's a lot of tidal waves in this area because of the Ring of Fire, and these coasts are always kind of at a danger of having to deal with those sorts of things. Let's talk about some special tectonic circumstances. For instance, hotspots are areas of the lithosphere that burn just a little bit more hot, and these places there will be volcanoes that form in the middle of a plate. And so they can burn through the crust and eventually create new land masses. Hawaii is one of those places. So that island is in the middle of a plate. And so due to the motion or whatever, these Hawaiian islands have slowly been growing over the time as the plate has moved. There are also supervolcanoes, which are just large magma chambers that could cause unparalleled eruptions. Supervolcano eruptions can cause short-term climate change or ice ages, and volcanoes of this size are monitored constantly by governments and scientists to make sure that we know if and when they will erupt. We also have begun to have plans in place to try to alleviate the stress of these supervolcanoes so that they don't actually erupt. We haven't actually utilized any of these plans yet, but it's definitely something that the scientific community is working on. One of these supervolcanoes is the Yellowstone magma chamber. It's the largest one in the United States, and it's 55 miles wide and 40 miles long and 10 miles deep. It is ginormous. And if it were to actually erupt, it could blot out the sun in the United States for years. That's how much ash and soot would be launched into the air. It would change life on Earth as we knew it for a very large portion of the population. So let's talk about some conclusions about plate tectonics. Okay, a strong understanding of plate tectonics allows us to try to mitigate disasters, whether it be a volcano, an earthquake, mudslides, tsunamis, or any of these things. It's all caused by tectonic activity. So an extensive global monitoring system has been set up in an effort to try to stop these disasters from being as bad as they could be. It's also good for us to understand the past so that we can understand what's going to happen in the future. Understanding what happened before can make it a lot easier to see what is going to happen in the future. Thank you guys so much for watching this episode of General Science about plate tectonics. Next time, we're going to go a little bit more in depth about volcanoes, and we're going to follow that up afterwards with another video on earthquakes, and then we'll move on from there. Thank you guys so much for watching, and I can't wait to see you again for some more General Science. See you later.